Exponential equations. This is an exponential equation. First method, common base. When you have a problem, you first check to see if both numbers have a common base. So try to find a common base for 27 and 81. If you get 27, you can see that 3 times 3 times 3 gives you 27. 3 times 3 is 9, times 3 is 27. So 3 to the power of 3 is 27, and the base there is 3. With 81, 3 times 3 times 3 times 3 gives you 81, because 3 times 3 is 9, times 327 times 381. So you can say that as 3 to the power of 4, and the base is also 3. So both numbers do have a common base. I screwed up there, sorry. So you can rewrite it as 3 to the power of 3 in parentheses and then 3x equals 3 to the power of 4. So you can multiply the exponents, so it would be 3 to the power of 9x equals 3 to the power of 4. When you have numbers with a common base, the exponents have to be equal to. You see, the common base and the exponents have to be equal to, so you can get rid of the bases and just write the exponents. And now you solve for x. Can you do that yourself? X equals 4 over 9. That is the answer.
I'll call you after my blood is drowning in alcohol.
Second method. This is when we have different bases. Sorry, I kind of screwed up. Our equation is 5 2x equals 130. Since we don't have a common base, we have to find the log of each side. So log 5 2x equals log of 130. Thanks to the power property of logarithms, 2x is supposed to go to the other side. 2x log 5 equals log 130. Now, we want to isolate x. Therefore, we have to divide 2 log 5 on both sides, leaving the x by itself. Now, we have x equals log 130 divided by 2 log 5. Now we have to calculate it using a calculator. No, you can't. Can you do it yourself? I doubt it. So, oh my god. The answer is 1.5. Yes. Yes.
Oh, give me love, oh, give me love.
Third method. Using logarithmic properties to solve an equation. So this is our problem. Since we are adding both logs, we can write it as multiplication. So we write it like this. Now we have to get the base of the log and put it to the power of the number that's on the equal side. So since there is no base, we can write that as a 10 and put it to the power of 1. And you rewrite it like this. 10 to the power of 1 is equal to 10, so we can just take away that 1 and write it like this. And now we have to distribute the x on what's inside the parentheses. So we get x squared minus 3x equals 10. But we don't want that 10 there, so we subtract it on both sides to get rid of it on the equal side. And you can rewrite it like this. X squared minus 3x minus 10 equals 0. So to solve that, we need to factor. So we put it in the square and solve it. To put x there, so it gives you x squared.
Me cago en ti.
And we need a minus 10 there. So
Trouble.
5 times 2 gives you 10, but we need a negative 10. So we put minus 5 and it gives you negative 10. 2x and minus 5x. Minus 5x plus 2x gives you negative 3x, which is what we needed to solve this. So that is our factor. X minus 5 and x plus 2 gives you 0. Now we need to take the x's of both factors. X minus 5, the x is equal to plus 5, and x plus 2, the x is equal to negative 2. And those are the answers. Now the only thing that's left is to check if it's right.
The pretty girl, and perhaps be